Hi, in this video I'm going to introduce a new Galaxy instance that we have made available to the general community. This is produced by the Bioinformatics Core Facility at the University of Manchester in the UK. Now, the purpose of this is to support a number of videos that I actually produced a long time ago in 2015. And although this is pretty overdue, it's still applicable to the tools that are used in those demonstrations. The purpose of the Galaxy instance is to provide a simple ChIP-seq analysis pipeline that anybody could use on their data. And I guess the advantage of this pipeline is that it contains a series of analytical tools that are not already available on the main Galaxy instance. Most of the tools are available on the Galaxy toolshed, but we're aware that a great many people are either not able to or not willing to create their own Galaxy instances, which is not without its problems. So in this video, what I'm going to do is just give you some details about how you can access the instance, some requirements that you need to consider, and just a bit of an overview about what is possible. So to access Mintaka, you'll need to follow the following URL, which is mintaka.ls.manchester.ac.uk. And when you arrive, please look through all the information that is presented on the landing page. Of note is that there are a number of terms and conditions that you'll need to agree to before using the service. And if you do use Mintaka in your work and then go on to put that in a paper, we would request that you acknowledge us in the paper, and we've created a statement that you can put in the paper for that purpose. When you are using the service, if you have any problems, you can contact our Galaxy admin Peter at this email address. Also, if you're running tools and one of them fails, which will be seen by a red coloured box instead of green shown here, and there'll be a bug icon with actually a picture of a bug, and you can click on that and send a bug report. But please remember to add as much detail as possible so we can follow that up for you. In order to start using Mintaka, you'll need to create a free account. We don't require many details from you. It's just enough to set up a space for you to keep working from session to session. You're given a quota of 50 gigabytes, and the files in there will only be kept for 30 days. So remember that if you are working through a piece of analysis, to download everything you need before that 30-day expiry. 50 gigabytes sounds a reasonable amount, but sequencing files can be quite large. Now, our recommendation and the purpose of this service is that you start with already mapped reads, so pre-mapped reads, preferably in the BAM format. In this way, you should be able to easily perform a ChIP-seq analysis with a chip and an input sample, and then carry on with the downstream analysis. As soon as you've performed FastQC and Max, you can then delete the BAM files, as you shouldn't need them any further. Files can be uploaded into Mintaka either by directly uploading files from your computer, or if you have files on a web server, you can attach a URL where those files will be uploaded from. Again, really would heavily suggest that you use BAM files for the starting point of your analyses. So, as I said at the start, we have a number of tools which, although they're on the Galaxy Toolbox, we've have them available here to create a simple ChIP-seq analysis pipeline. So if you were to start off with two BAM files, one for chip and one for input, you could then run FastQC to check on the quality of those reads, and then run Max to identify binding regions on the genome. Currently, we're providing Max 2.1.2, which is the latest at this point, but we intend to keep this updated in the future. If you look at the Max tool itself, you will see this versions tab. So at the moment it's using 2.1.2, but you can also see that there is an older version available, and this will no doubt be updated in the future. Now, after running Max, this is a reasonable point to delete the sizable BAM files and carry on with the downstream analysis. The rest of this pipeline has been described in previous videos, but briefly, we can filter the binding regions by their fold enrichment scores and create what I call a summit region of 200 bases that are centered upon the summit peaks. Now, this is useful for other downstream analyses. For example, CEAS allows one to identify where binding regions reside in relation to genes. And also from the 200 base regions, we can extract genomic sequence and pass this on to EDA2, which will perform a simple motif discovery analysis. We can also identify genes that are within a close vicinity to the binding regions, and we provide our own software, RNA chip integrator, to do this. So before I stop, just to let you know that Mintaka is actually named after one of the stars in Orion's belt, the constellation, in case you were wondering. Please let us know if you find it useful or if you have any suggestions. Thank you very much. Bye.